Hey everyone, Miss Negro here. Today we are going to continue our work analyzing polygons on the coordinate plane. So get your pencils and notebooks ready. So take a second and do that. And I would write this on the top, analyzing polygons on the coordinate plane on the top of your notebook. All right, so if you haven't already done so, write analyzing polygons on the coordinate plane on the top of your page. Sorry, this is all out of whack. Okay. Last week, we worked on finding the length of a line segment on the coordinate plane if we knew the ordered pairs for the endpoints. So remember, ordered pairs are those x comma y values right there. So you can find the perimeter of the polygons on the coordinate plane. So when we think back to perimeter, we know that that is adding up all of the sides because we want to find the total amount of the outside area. So like a fence maybe. So find the lengths of the sides and then add them together. So we would add all of these together, x plus x plus x plus x, and that would give us the perimeter of that little fence that I just casually drew. Okay, so that was just a quick friendly reminder on what perimeter is. Okay, so first let's review finding the length of a line if we know the endpoints. In this problem, we are doing that with a line that happens to be on one side of a triangle. So this is an old state test question. A triangle has vertices on a coordinate grid at the points of J, which is located at -1, 5, K, which is located at +4, 5, and L, which is located at 4, -2. What is the length in units of KL? Just some important things to notice. Vertices are these little points on the triangle. So let's say that we had drawn this triangle, right? So each little point would have a name, J, K, or L. Okay, so we can do this one of two ways. So we're only focusing on line KL. So that means the line that goes from this point here, to this point here. So the first way we can do this is, I'm gonna rewrite it because I just kind of scribbled it out. 4, 5, and L is 4, -2. Okay, one way that I like to do it is I look to see which number in the ordered pair is the same and I cross it out immediately. So that means that this line, they both have in common 4 on their x-axis. Okay, so we have these two. So I can do the absolute value of 5 plus the absolute value of 2, which means 5 plus 2, and that gives me 7. Okay, that's one way. Another way that I could do this is to draw it out. So I'm gonna do a quick sketch. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. All right, I'm gonna do 1, 2, 3, 4, 5. Okay, I think I have enough points to start plotting. So I'm gonna plot K first, which is 4, 5. So I go over 4 and then up 5, which is about here. Okay, now, -1, -2, -3. I thought I did them all. Whoops, sorry guys, -5. Okay, so you've done this one. Now I'm going to plot, so that was plot point K. Now I'm going to plot point L, which is 4, -2. So I go over 4 and down to 1, 2, which is here. Okay, this is where it gets a little tricky because I don't have my grid. So I'm gonna kind of shade, see I already messed that one up. There's that, here's 4, 3, 2, 1, here's my 0, -1, and then -2. Okay, so now I can count the spaces between. So here's 1, 2, 3, 4, 5, 6, 7. So if I were to draw and count, I got 7. So I could do it either looking at these, seeing which number in the ordered pair they have in common, crossing them out, and then finding the absolute value. Or if I want to be super safe, you draw it out and you count the spaces. So either way, the distance between those two is 7 units. Okay, let's keep going. So now we're going to apply this to perimeter. So the coordinates of the points below represent the vertices on the rectangle. So again, vertices are these little points right here. Okay, so P is at 2, positive 2. Q is at 6, positive 2. R is at 6, positive 5. S is at 2, positive 5. What is the perimeter in units of the rectangle PQRS? Okay, so it looks like I need to probably graph this whole thing, but let's see what we have. These little notes over here. It says find the length of each of the sides. Add them together. Hint, I love a good hint. Sketch a picture to stay organized. Okay, so I'm gonna start by sketching out my picture. Hopefully this one looks a little bit better. So here's 1, 2, 3, 4, 5, and 6. Positive 1, 2, 3, 4, 5, and 6. Negative 1, negative 2. Oh, by negative 3, negative 4, negative 5, negative 6. It's getting a little sloppy down there. Sorry, guys. Negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Okay, now I'm going to start by plotting these points. So the first one that I'm going to plot is P, which is at positive 2, 2. So I'm going to go over 2 and up 2. And this is point P. Oops, sorry. Okay, my next one is Q, which is at 6, 2. So I'm going to go over 6. I'm going to draw a very fine line so I can try and keep them on the same one. So over 6, up 2. Here is Q. Ooh, I love that it rhymed. Over 6, up 2. That is point Q. Okay, sorry. Next one, R is at 6, 5. So I'm going to go over 6 and up 5. So again, I'm going to draw, oh boy, this line here, 6. And that is point R. And then my last one is 2, 5. So over 2, up 5. And that's point S. Okay. So now I'm going to connect these. So here is our rectangle. So now, actually, this is what we're focusing on. Now we want to find the perimeter. So we need to start by finding the total of each side. So if I were to count from here, here's 3, here's 2. So from 1, 2, 3, I made 3 jumps here. So from 5 to 2, since they're in the same quadrant, you can also subtract them because they're all in quadrant 1. That is 3. So the same thing here. I'm going to just draw my little ticks again. Here's 3, here would be 4, here would be 5, here's 6. Okay, 1, 2, 3, 4. Okay, same thing. I could have done 6 minus 2, and that gave me 4 because, again, all in the same quadrant. So I know that this side is the same, but I'm going to count anyway because here I am. 1, 2, 3, 4 jumps, and the same thing here. 1, 2, 3. Okay. So now I found the length of each side. My next step is to add them all together. So on the side where I have a little bit of more room, I'm going to write 3 plus 3 plus 4 plus 4. 3 plus 3 is 6 plus 4 plus 4. 6 plus 4 is 10 plus 4, which gives me 14 in my nice, beautiful Dorito. All right, so first step, I plotted all these. I counted the sides, found the length of each side, and I added them together to find the perimeter. All right, moving on. Here is our last problem, and it features a really, really great name. I don't know if you guys feel the same way, but like, Lauren, what a great name. All right, so Lauren is designing a field for her alpacas, and she wants to enclose the field with a metal fence. The vertices of the field are A is at -8,4, B is at 10,4, C is at 10, -6, and D is at -8, -6. Okay, so it has 4 points, so it sounds like this fence is probably going to be a rectangle. Since you know, in Queens, I have plenty of room for my alpacas. I really need to get this fence going. So if each square is 1 yard, how many yards of fence will she need? If each yard costs $14, how much will the fence cost? Okay, so before we even get into that, I'm gonna start by making this fence on my coordinate plane here. I always like to put in the numbers for myself because as you can see, this one does every other, and I like to have it super clear because that's just who I am as a math person. So I'm gonna put in all of these odd numbers right now. This is 4, 5, 6, 7, 8, and 9. Okay, it just is more visual for me. All right, so my first one is at -8, +4. So I need to go over -8. Oh my goodness, I forgot the most important part. This right here is our 0. I'm gonna go over -8 and I'm gonna count up for 1, 2, 3, here's 4. Okay, and I'm going to label that is point A. Okay, now I need to find point B, which is at +10, +4. So we're all the way over here, +10 and up +4. 1, 2, 3, and 4. Okay, that is point B. Check, check. Okay, point C, I'm gonna do in this blue color, which is +10, -6. So I go over 10 and down 6. 1, 2, 3, 4, 5, and 6. That is point C. And point D, I'm going to do in this green color, and that is -8, -6, -8, and then I go down 6. 1, 2, 3, 4, 5, 6. Okay, and that is point D. Okay, now I'm gonna draw beautiful straight lines. I'm a big fan of using a ruler when doing them, but unfortunately, I left all of my rulers at school, so I'm gonna just try my best to make this as straight as possible. Okay, so I've plotted all of these points. Okay. Whew. So if each square is 1 yard, so I'm gonna write 1 square equals 1 yard. That's called a scale. You'll talk more about that in 7th grade, but that's called a scale. How many yards of fence will she need? Okay, so now I'm gonna do the same thing as before, and I'm gonna start counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so that's 18 yards. I can even put that in there, 18 yards. Okay, now I'm going to, so I can assume that this also is 18 yards. Okay, now I need to find the length of the sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 yards. And then over here we have 10 yards. Okay, so now to find out the total amount of yards I have, I'm going to add all three of these numbers. So I'm going to do 18 plus 18, 8 plus 8 is 16, carry the 1, 36. Check, check. So now I have 36 plus 10 plus 10. 36 plus 10 is 46, plus another 10 gives me 56. So I will have 56 yards of fence surrounding my alpacas. Okay, next part. If each yard cost $14, how much will this fence cost? Well, if I know that each one, so I can actually set this up as a ratio. Here we go, guys. 1 yard is equal to $14. How much money to get to 56 yards? So 1 times 56, so I need to do 14 times 56. I love ratios so much. So I'm gonna do my work off to the side. 56 times 14. All right, 6 times 4 is 24, 20, 21, 22. Okay, put my 0. 5 times 1 is 6, 5 times 1 is 5, 4 plus 0 is 4, 6 plus 2 is 8, 2 plus 5 is 7. So I need $784 in order to fence all of my alpacas in. All right, guys. I hope that this was informative. I'm so thankful that you guys helped me make this fence. So now that all the alpacas that I have living in Queens with me have a really nice and spacious place to play. All right, I'll see you guys tomorrow. Bye.